Port channel. You see, the word has got meaning. You take more than one port. This is how the switch ports will be, 2 rows. You take more than one port, or 3 port, or 4 port, aggregate them, bundle it, group it. That's why we call it as channel it. Channel. Ports channeled, grouped. See, Cisco calls it as port channel or ether channel. Some other vendors don't call it as ether channel, they call only as port channel. Some vendors call it as port group. Some call it as port bundling. Or port aggregation. All means same thing. Now, why do we need to do that? Why we need to do port group, port bundling, ether channel, port channel? Why we have to bundle? You see, whenever we have redundant links connected between switches, to prevent loop, STP is going to block STP is going to block 3 of this port. Only one is active. This is to prevent loop. And every one of us know this. Whenever you have redundant path, loops are possible. To avoid loop, spanning tree protocol, that is what I called as STP, will block. By blocking, it makes the link standby. So these links are now standby links. And only one link is active here, which is the green one. So we were very happy. Wow, hooray, no loop. We solved the problem of loop. But the problem is, we have paid a big price for that. What price? You spent money on these 3 links, which you are not able to use it. You block the port, that's the price you have paid. By blocking the port, you avoid loop. So the money that you spent on those links, waste. Not only wire cost, even these ports, these ports neither connected to some server nor being used by the switches. In another word, if you have 100 meg on each link, you're supposed to enjoy 400 meg, but you only have 100 meg. So you have wasted a lot of resource by using spanning tree. Spanning tree is good. It prevents loop. But it is also bad because you are not able to fully, optimally utilize the resource that you have at your proposal on your desk. You're unable to use the bandwidth that you're supposed to use. See, when you have two bikes and there are two people in the house to use the one to use the bike. There are two adults in the house, but if the rule of the house says one bike should be standby, will you be happy? Then only one person can use the bike. The other person has to wait for the bike to get free. Because at the same time, you cannot use two bikes. Let's say that's the rules of your house. Won't be nice, no? Then why did we spend on both two bikes? Now, how do we solve this problem? This problem is solved by aggregating this link. You can aggregate same four links physically, but after aggregating, they appear to be one link. That four link is now one link. Because it is one link now, you have the complete 400 meg. When it was separate, it was only 100 meg you are able to use. Because when there is a broadcast, packet will go like this and come back like this and form loop. But when it is only one link, an aggregated link instead of four links, though physically it is four, it is still one link. According to the switch, that four link is seen like this. Both the switches see like this as one single link. To identify that one single bundled link, a name is given called PO1. This one depends on what number you give. If you give 1, then it will be PO1. If you say 2, then it will be PO2. Port channel, PO means port channel. The original name of this interface is fast Ethernet 001. Like this, fast Ethernet 1, 2, 3, 4. But after bundling, it gets one common name for all this four link. And the common name is PO, port channel. Let me quickly show you this. As we discussed, four links. I have also taken four links. Shortly, you will find that three links going standby, one link will become active. You see this side on the right hand side, all became green. On the left hand side, only one green, which means switch 1 is blocking 3 ports out of, let me just name this as switch. Okay, switch 1, if you check show spanning tree, you can see 3 blocks. Except F01, all the rest are blocking. And the cost is 19, you see, cost is 19. Now I'm going to aggregate this 4 link. How? Go under 4 links. Before that, I want to show you show IP interface brief. This is the command that will show you all the interfaces and their status. When I type show IP interface brief, I can see Gig Ethernet, I can see VLAN interface, I can see fast Ethernet. But what I don't see is port channel. Do you see any interface named port channel here? No. But after I aggregate, you will see a new interface created called port channel, which is a representative of all those 4 physical links. We are bundling these 4 links as one single link, and that single link will be called as port channel. Now, let us go into the 4 interfaces by typing this command interface range f0/1-4. These are the 4 interfaces. These 4 interfaces. And here, make all the interface as access or trunk. It should be any one. You cannot have one interface as access, another interface as trunk. All 4 should be trunk or access. Let me make it as trunk. Switch port mode trunk. Then configure that ether channel or port channel. Listen carefully. Channel group command. Channel group and give a number, any number between 1 to 6. That number will be the number of the interface that it creates. Say, for example, if I say channel group 3, mode on. You see, immediately an interface called port channel 3. Why 3? Because I use the group name as 3. Let's go and verify now. You see, show IP interface brief. Earlier you were not seeing this interface. Now you see this. This interface is the representative of these 3 physical links. This 4 physical link is grouped together and got a common name to identify the group of ports called port channel 3. Let me also go to the other side and configure port channel. Host name switch _2, interface range f0/1-4, switch port mode trunk, switch port, sorry, not switch port, channel group. I gave number 3 there, give the same number, mode on. That's it. You see here also that interface got created. Now, earlier when we were checking on switch 1, the spanning tree command, you saw only one active and all other are blocking. All other, see, only one was forwarding, all the other were blocking. So out of 400 meg, you are using only 100 meg. And the cost was 19 for 100 meg. But now, same switch show spanning tree, the cost is only 8. Why? Because it's 400 meg. The capacity of this PO3 is 400, not 100. You see, it's a shared type interface. But here it was not shared type, it was point to point, physical. Now we have aggregated all this 4 and it is shared type. Did you understand up to here? Right. Now, we have all the links active now. You see, all are green. Now, how do you know whether all are active? When you type show spanning tree, you cannot see all 4 links. But when you type this command, show ether channel summary, now you see the group number 3, interface name is PO3. Capital S means it's a layer 2 ether channel, which means there is also layer 3, which we are going to learn a bit later. If you see R instead of S, then it is layer 3. What is layer 3? Routable one, where you can provide IP address. In the sport channel, you cannot provide IP address because it's layer 2. Capital U stands for the port channel is in use. It's rightly active. And now if you see these 4 interface or the member in that port channel 3. P means what? It's the member of a port channel. So these 4 ports are grouped, bundled, aggregated, channeled as one single virtual port called PO3. And that virtual port is not a layer 3, it's a layer 2 port. Did you understand up to here? Now, we got 4 ports all active. How is the load shared across this 4? There is an algorithm called round robin. We all learned those things in colleges, round robin. So using that algorithm, it goes in a round robin fashion. Now, based on what? Let's see. Show ether channel load balance. I'm asking, how is the load balanced across this 4 link? It says, if the source MAC address is same, then it will put the traffic on the same link. If the source MAC address differs, it will put on another link. For example, you see, let's say the MAC address of this PC is A, this PC is B, this PC is C, and this PC is D. Now, when A send the packet, it puts in the first link, goes to C. If again A send the packet, but this time destination is D, but because the source MAC address is same, that will also go in the same first link only. That is what it means. Source MAC address. Only when the source MAC address changes, it will put in another link. Now, if A is talking to C, it takes the first link. If A, oh no, no. And if if B talks to C, if B talks to C, it takes a second link because the source is not the same. But unfortunately, the return traffic, because the source is same, it will come on the first link. You understand? So load sharing is based on the source MAC address. If you don't like this, I don't like this. I want it to be based on the destination. You know your network better. What? Let's say you don't have B and you got many destinations, many, too many, C, D, E, F. In this case, this algorithm is not good for you. Source MAC address, which means then every time only the first link will be used. The other three, even though they are available to use, cannot be used. Why? In this direction cannot be used. Maybe in this direction it will use. C replies, it will go in the first link. D replies, it will go in the second link. E replies, it will go in this link. F replies, it will go in. Okay. But while going, it will always go in the first link because the source MAC address is same. So what you can do is you can use that AND operation or OR operation algorithms. Better go with OR. I'll show you. Port channel load balance. Sorry. You see, OR. If anyone, either source or destination is different, it is going to take different link. You understood what I'm saying? If anyone differs, it will take different path. You can also use IP if it is layer 3. We have not seen layer 3 so far, so don't worry about IP address. This is the default one. You also have destination MAC based, destination IP based. Now let me change to this one, source or destination. That's it. Let's go and verify, show load balance. You see, I have changed. Do it on the other side if needed. Depending on your topology, you need to choose the algorithm. Ether channel or port channel load balance. Put question mark, it shows the availability of algorithms, source, destination. Now, yeah, okay. What is next? You see, right now when I type show ether channel summary, it shows the port channel is up, it's in use. Now I'm going to remove the configuration of ether channel on R1 on switch 1. How? No port channel, no interface, port channel 3. I removed. Now if you go and check show ether channel summary, it's no more. The bundle is no more. But the other side still believes that, you see, show ether channel summary. They still have this 4 in the bundle. Though it is down, it is capital D down. Though it is down, but still the bundle here is still there. How it knows it is down? Because I removed that. Let me simply try to say interface port channel 3. No shut. It won't come unless you add some interface. Let me go and add one interface. Interface F0/0, only one. So I'm not using the range command. Channel group. Sorry, one. Channel group 3 more. Okay, let's check. Show IP interface brief. You see the port channel is there, but it is in down state. Sorry, here. The reason is these interfaces are down. Let me bring this interface up. Please pay attention. Please pay attention. On switch 1, show ether channel summary. I just got only one interface as a member. But switch 2, no, this is not correct. No, you see, that side only one interface in the bundle. But this side, it says I have 4 interfaces in the bundle. Now, your network is going to behave abnormal. This side, it will consider the bundle and send the traffic. Maybe it is sending, let us say, it is sending through this third link. But this guy is simply only responding to the first link, sending only in the first link, because the other 3 is not in the bundle. Not in the bundle. So whatever you send through this 3 link is going to go get dropped here. This is because we manually turned on the port channel. You saw me typing the command mode on. Mode on. I'm owning it. I'm owning the port channel. When we on, we need to be very careful. We need to make sure this end of the wire and this end of the wire and all these 4 ends of the wire and other end of the 4 wire are correctly grouped. Instead of grouping these 2 ends, if I group this 2 and some other 2, problem. So when we do on mode, we need to be careful. We need to trace the wire and see if exactly the other end of the wire is the bundle, not some other port's wire. If not, you better depend on a protocol to check it. Don't go with on mode. On mode is static mode. I did on mode, both sides. Instead, instead of going on mode, you say that I want these 4 protocols, 4 ports to be in the bundle. on both sides and enable a protocol to verify whether the ports are correctly in place. Only if it is in place, only if it is correctly configured to be a member of the bundle, the port channel should come up, the virtual link should come up. For that, you have two protocols. One is industry standard protocol LACP, link aggregation control protocol. The other one is Cisco proprietary protocol called PAGP, port aggregation protocol. Link aggregation protocol, port aggregation protocol. You can use this or this, both are good. In this you have two modes. One is here auto, desirable, active, passive. Passive and auto is same. Desirable and active is same. What is desirable and active? What is desirable? If I put desirable this side, this will initiate the negotiation of bundle on the other side. That is active. Even desirable also same. If you put desirable, you are enabling PAGP. If you are putting active, then you are enabling LACP. If you put desirable, it means the desirable side will go and initiate the port channel negotiation. This will go and tell to the other end, hey, shall we form a group? Shall we form a bundle on these four links? And if the other guy says yes, then bundle comes up here. If the other guy says no, then bundle won't come up. So after negotiation, it brings the bundle up. Let's see that. Look at this. I'll remove the port channel. I'll remove the port channel. This is why it is dancing. I don't understand. No interface port channel 3. I'll remove on both sides. Okay. On here also, on the other side also, I'll remove. No interface port channel 3. Then I'll go under those interfaces. Sorry. Okay. Now if you see show spanning tree, all focus only on 1, 2, 3, and 4. 5 and 6 are connected to this computer. If you see the picture, they're connected to computer 5 and 6. Ignore those things. Focus on 1 to 4. They are no more in the bundle. They're no more in the bundle and they are blocking. Okay, so out of 4, 1, 2, 3. Okay, where is the 4? 4 is shut down. Interface of 0/1. 4 shut. 1/4. Why? Show IP interface, something is not normal there in F0/4. Why it is down? Oh, here it is administrator down. That's okay. Now, if you see, there is no bundle here. Show port show spanning tree. You can see 4 is blocking, 2 is blocking, 3 is blocking. Only 1 is forwarding. Only one is forwarding out of 4. So we have to configure port channel, but with the help of a protocol, so that the protocol will negotiate either side and then decide whether to bring the port channel up or not. எல்லாம் சரியா இருக்கும் பட்சத்தில் மாத்திரமே அந்த போர்ட் சேனல்ங்கிற அந்த விர்ச்சுவல் இன்டர்ஃபேஸ் ஆக்டிவ் ஆகும். இல்லைன்னா எப்பயும் போல 4 லிங்க் இருந்தா என்ன நடக்குமோ அது 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 படி நடக்கும். ஸோ ப்ரோட்டோகால் யூஸ் பண்றது ரொம்ப நல்லது. நீங்க பிஏஜிபினா யூஸ் பண்ணுங்க, எல்ஐசிபினா யூஸ் பண்ணுங்க, ரெண்டுமே ஒண்ணுதான், ஒரே வேலையை தான் பண்ண போகுது. ஆனா பிஏஜிபி யூஸ் பண்றவரா இருந்தா ஆட்டோ டிசைரபிள்ங்கிற கமாண்ட் தான் யூஸ் பண்ணணும். எல்ஐசிபி யூஸ் பண்றவரா இருந்தா ஆக்டிவ் பேசிவ்ங்கிற கமாண்ட் தான் யூஸ் பண்ணணும். மிக்ஸ் பண்ணக்கூடாது. ஸோ இஃப் யூர் யூசிங் பிஏஜிபி யூஸ் ஆட்டோ அண்ட் டிசைரபிள். Don't say one side auto, another side active, which means you have two different protocols. They don't understand. And PAGP is a Cisco proprietary. So only between two Cisco switches you can have PAGP. LAGP is industry standard. Better go with LACP. Better go with LACP. So I'm going to enable using LACP. Listen here. Interface range F0/1-4. Channel group. Give any number. I'm going to give 1 this time. You see here. Mode. You have auto and desirable, which is PAGP command. Active and passive, which is LACP command. Which is industry standard, LACP or PAGP? Which is LACP. So I'm going to use active on either side, or if you want, you can say one side active, one side passive. It's up to you. I'm going to say mode active. I no need to say I want LACP. If I say active, it will automatically enable LACP. Now you see, only on one side I have enabled, isn't it? Now if you check show port channel, sorry, show IP interface brief, the port channel is still down. You know why? The other side is still not ready. The protocol says other side is not ready. So when you type show spanning tree, you still see that 4 link. Show ether channel summary. Even though you have said that 4 port to be a member of the bundle, because it is D, capital D down, they are no more in the bundle. They are considered to be in the bundle, but they are not really in the bundle. They are separate. When will they become a bundle? Only when other end is configured. So I'm going to configure the other end. Interface range F0/1-4. Channel group 1 mode. That side I said active. This side you may say passive also, it's okay. Or you can say active also, both sides, nothing wrong. But don't say both the side passive. If you say both the side passive, problem. What problem? Both are waiting for other to initiate the conversation, and no one is going to now initiate because both are passive. ரெண்டு சவுத் இந்தியன் பாய்ஸ் ஏரோப்ளேன்ல பக்கத்துல உட்கார வச்சீங்கன்னா முடிஞ்சிச்சு கதை. இவனுக்கு தூக்கமே வரனால இவனும் தூங்குற மாதிரி நடிப்பான், அவனுக்கும் தூக்கமே வரனால அவனும் தூங்குற மாதிரி நடிப்பான். 2 பேரும் பேசவே மாட்டான், அப்படியே வந்து இறங்கிடுவாங்க. ஏன்னா 2 பேருமே பேசிவ். சவுத் இந்தியன் பாய்ஸ் ஆல் பேசிவ் ஒன்லி, நோ டாக்கட்டிவ். வெரி ஃபியூ ஆர் டாக்கட்டிவ். அதுவே ஒரு அமெரிக்கன் பாயையும் ஒரு சவுத் இந்தியன் பாயையும் உட்கார வச்சிட்டீங்கன்னா அமெரிக்கன் குறைஞ்சு எடுத்துருவான். ஐம் டாக்கிங் அபவுட் குட் பாய்ஸ், ஸ்மார்ட் பாய்ஸ். So both side active is good, or one side active, one side passive is also good. But If you put both side passive, then conversation will never occur. I said passive this side. You see, the port channel also has come up. Show port channel. Sorry, show ether channel. Still still the negotiation is going on, I believe. Let's go to the other side. Yes, the negotiation is going on. Okay, now only it has come up. Let's check. So ether channel summary. You see, only after negotiating it comes to P. Before it was I. I means it was standalone. When it was standalone, when we checked show spanning tree, it was not grouped. Now it is grouped. 1 to 4 is grouped. On the other side also you can see grouped. You see, they're all a member of port channel because LACP has negotiated show spanning tree. Here also you can see the group. So using protocol is the best idea. Don't use on mode. Use LACP or PAGP. I used LACP. You can try PAGP at home. What is going to be there in our next class is layer 3 port channel. How can I have routing? How can I have IP address? How can I make this layer 2 port channel as layer 3? Right now, it says capital S, layer 2. Tomorrow, we are going to have capital R instead of S here, using that same LACP or PAGP. Any question on today's class? Any question on today's class? All right. We'll stop here.